and it minimizes it when you click on it, and then if you want to maximize it, you click on it again.
Okay, got it.
Okay. Now tell me where I should click on this page.
There's only one course open, which is that college algebra to the left.
Let me go ahead and click on that. And I did hit record, I believe. So the session will be recorded, and then I will send you an email tomorrow morning as to how to watch it if you want to.
Okay, now see that yellow box that says launch course?
Uh-huh.
Hit that.
Okay.
Okay, so
see where you might remember where we got to when we were at your house. I'm not exactly sure. It looks like we did that.
If you scroll up a bit, so if you hit lessons, I want to say it's lessons, hit that lessons option, see what that does.
Okay. Should we start at the first one, the top?
No, that just shows what's kind of, I think, outstanding. Hit all.
Okay.
See what that does.
All right.
Okay, so we got through pretty much chapter 1.
Okay.
So what I want to look at is chapter 2, because it's all about linear equations and just kind of, I want to kind of review this chapter.
You direct me. You tell me what you'd like to look at next.
So yeah, let's start with 2.1a and just kind of work our way down.
Okay. And practice, continue?
Sure, let's look at practice. These are just problems that obviously...
That's the best way to learn, is doing problems. Definitely is the best way. All right, now what I'm going to do is minimize this a little bit so that I can put my drawing tablet on there also. And consider the following equation. What happened to it? What did I do? It disappeared on me.
Can you scroll up?
I don't see a scroll bar. Hold on a second. Let me see if I go back. Hit practice again. Okay, so 2x minus 3y equals 4. And determining the missing coordinates. Okay. So what the missing coordinate is the y coordinate. They have given us the x coordinate, and they want to know what the y coordinate should be.
Mm-hmm.
So basically what we're going to have to do is solve this equation for y. There's a couple of ways to approach this. One is, let's go ahead and substitute the value they gave us for x, minus 1.
Mm-hmm.
That's probably the best way to start this problem. Anything that I do that you don't understand, please stop me.
Okay.
It's the next, okay, and I'll multiply those two together. So I have minus 2 minus 3y equals 4. What's the next line? The next thing I should write here. Let me put this out of the way here. In other words, whenever what we're really trying to do is solve this equation for y.
But don't we have to isolate y?
Yeah, we want the final line to be y equals something.
Mm-hmm.
And when you're solving equations, generally, there's not always exactly one way to go, but generally you want to get rid of any numbers that are being added or subtracted. We have this -2, so let's get rid of that. How do I get rid of that?
You put +2, -2.
Okay. So what does that leave on the left side? Read the next line to me.
Oh, so -3y equals 4 + 2.
Which is 6. Okay.
Yeah.
Now I need to get rid of that.
Mm-hmm.
That is currently a multiplier.
Mm-hmm.
So you always do the opposite of what it currently is doing. So what's my next step?
Would be, you would need to add 3.
Not add, but divide by -3.
To divide 6 by -3.
Yeah, because -3 is a multiplier, I always want to do the opposite, which the opposite of multiplication is division. Okay, so by dividing both sides by -3, gets rid of that -3 on the left side.
Mm-hmm.
And now my final answer is what? Y equals
-2.
And that's what goes in that spot right there, -2. So when x is -1, y has to be -2.
Mm-hmm.
Now, I should be able to enter this answer, and I guess I just enter it as -2. These are always a little tricky. Sometimes you don't enter it exactly the way it likes. Okay. Next. I just got a message that's saying I may be getting a degraded audio quality. Can you still hear me, Darren?
Yeah, that's fine.
Okay. Do you want to, should we try next? Not simple, right? Next, okay. And this one, same equation, I think. No, not quite the same, but close. This time, they're giving us the coordinates of question mark. In other words, that's the x coordinate.
Mm-hmm.
And the y coordinate is 1/2. So if we do the same process we did in the last problem, what should I do first?
Well, you need to get x by itself because we're solving for x, right?
Right. But let's go ahead, and last time you'll notice what we did was we substituted the x value right away as the first step.
Mm-hmm.
Well, what we want to do this time is substitute the y value. Because they've given us the y value is 1/2, then let's go ahead and substitute it. And by substituting it, now I'm going to end up with an equation that is only in one variable, x. And I can solve for it by just doing the algebra. Okay, now let me write the next line here, and then I'll have you take it from here. What's the next thing to do?
So you could
look for anything that is a number being added or subtracted to the variable. Well, that stands out. Let's get rid of that. By getting rid of it, I mean moving it to the other side.
Mm-hmm.
What do I do?
So do we add?
Yes, because it is currently being subtracted.
Mm-hmm.
So if I add 3/2, I get 11/2. Now, let me back up a second and make sure you understand how I got that. It's 4 plus 3/2, right?
Mm-hmm.
Well, that's 8/2 plus 3 halves. Whenever you're adding two things, you got to have a common denominator. That's 11 halves. That's equal to 2x. So what's the next step?
So
To raise
you would divide 11 halves by, well, actually, put the 2x over 2 and the 11 halves over 2.
Correct. In other words, what I'm going to do is divide both sides of the equation by 2. Now, that's going to leave x on the left, which is what we want. And let's talk about how we handle this thing on the right. When I have 11 halves over 2, probably the best way to look at this is I'm taking a fraction and dividing it by that fraction. And the way you divide a fraction by a fraction is you flip the bottom and multiply. So that's equal to 11 over 2 times 1 over 2, which is 11 over 4. And that's our answer.
Okay.
Now, you could have also seen that if we take 11 halves and divide it by 2, the 2's are going to both end up in the denominator, and I can immediately go to 11 fourths if I'm familiar with that calculation. If you have any confusion whatsoever about this, then turn it into a fraction divided by a fraction, and you probably know how to do that 100% of the time. All right. So 11 fourths is what we want to put in.
If you go to the keypad,
Whoops, hold on a second. I didn't put that in right. 11, it doesn't like my divide sign. It doesn't like that either. Oh, I got to go to the keypad here.
yeah, and then hit that blue box there on the right. Hit it again.
Ah,
Yeah.
okay. What did I get, 11 fourths?
Yeah.
Wow. That's a little annoying that you have to go to that keypad instead of being able to use the keypad on my keyboard. All right. First of all, do you know how to plot these 3 points on that graph?
So I get a little bit confused as to which comes first, the x or the y.
X always comes first.
So like that -2 on the x-axis would be over to the left, right? Left of the 0.
All right. So let's plot point A. So there's the x-coordinate. You can see where my cursor is pointing. And I want to go up to that point right there. So that should be point A. You with me?
Yeah.
Okay, point B, I don't even know how to have you tell me this, but if you watch how I do it, I think it'll become obvious. In other words, I start by going to the x-coordinate, -5, and now I'm going to the y-coordinate, which is up 4. There's B.
Okay.
And C, I go to the x-coordinate first, which is +5, and then I go to the y-coordinate, which is -2.
Okay.
Identify the coordinates of points A, B, and C on the graph. Okay, well, you must think that we have short memories.
Do you want me to tell you?
They just gave us the coordinates, right? Okay, well what is, oh no, I'm sorry, these are different coordinates. Yeah, no, these are not the same 3 coordinates that we just put on there. I was thinking that they were just giving us the same 3. All right.
But let me tell you what I think they should be.
Okay, what's A?
So A is -1. And that should be
That's the x-coordinate. What's the y-coordinate?
negative, is that 5? I can't see it very well.
Yes, it is. Okay.
Okay.
How about B?
B is 4, looks like 4, 3.
Yeah, I can do something. I think I can blow this up a little bit so you can see it a little bit better. And what about C?
C is 6, -7 maybe.
Yeah. All right. Hold on. Let's see if I can blow this up.
It's okay. I got.
All right. You can read it. I can't figure out how to blow it up. So, okay. So next problem. Yeah.
All right. So if you go back, see it says back to lesson. Hit that.
Okay. And I want to try two.
Go back to college algebra again. Okay, now hit chapter 2 again.
Okay, I get it. Now we got to go to 2.2.
Correct.
Okay.
You know, I think if we just do a few problems in each section, we should be good.
Yeah, and actually, we only need to go as far as you get to a point where you're comfortable, you understand it. We don't need to beat it to death. Okay. Our equation is 3y equals 0. There's a rule in algebra that says that if you multiply two things together and they're equal to 0, one of those things has to be 0. So y has to be 0. I can get that by dividing both sides by 3 if you prefer, but nonetheless I still get y equals 0. And that's the only solution to that equation. There is no other value of y that works. If I make y any number at all, then I've got a number times a number, and that's never equal to 0.
Okay.
Now I'm trying to figure out how it wants me to put this answer in. To plot a point, click on the position. You may move a point by clicking and dragging. Graph the line. Well, the equation is y equals 0. And they want me to put 2 points on there that will give me that equation. That's actually the equation of a horizontal line. In fact, that's the equation of the x-axis. So for me to graph that, is all I have to do is plot on one point on the x-axis and probably a second point, and that should do it. Notice that arrows ended up on both sides of that line.
Yep.
And that tells me it goes to infinity to the left and infinity to the right, but it's basically a horizontal line that is on top of the x-axis.
Okay.
I got to be a little careful about our ending time. I do have an 8 o'clock session tonight. So I don't usually set an alarm. I usually just leave it to my eyes to notice that I'm getting near 8 o'clock. In case I run over, please remind me. Okay, let's solve this equation.
So I would put 3x over 3 and make -15 over 3.
So So what's x equal to?
X equals negative, what's that? 5.
Okay. Now, horizontal lines are always y equals some number. Vertical lines are always x equals some number. So this is a vertical line that goes through the point x minus 5. Okay, so if I want to graph this point, all I got to do is graph 2 points above one another, and there's my vertical line. And it's at the right point. In other words, when it says x equals minus 5, that means no matter what y is, x is always minus 5. And you can see that it's minus 5 there, it's minus 5 there, it's minus 5 up there, it's minus 5 down there.
Yep.
So there's no y in that equation. And once you get the hang of this, you tell me when you want to skip forward if you feel like it. Although they get slightly more complicated with each question. Now, they want the x and y intercepts of this equation. First of all, notice that this is a linear equation, meaning it's a straight line. It's not a curved line. Okay. And here's the thing. In other words, if I were to graph this line, right offhand, I don't know how to graph it because it's not in particularly good format for graphing. But let me think for a second. The y-intercept's going to be somewhere there. The x-intercept's going to be somewhere there. So let's assume that were the line. Okay? And they want that point and that point. The upper point is the x-intercept. That's supposed to go through that. And the lower point is the y-intercept. In other words, that's the y-axis, that's the x-axis. Now, this is one of the few situations where you don't actually have to know what the slope is. To figure out the x and y intercepts, is the easiest way to really do it is I'm on the x-intercept when y equals 0, correct? In other words, if I want the coordinates at that point, it's the x-coordinate, comma 0. So to figure out the x-coordinate, I'm going to substitute 0 for y. And now I have minus 2x minus 3 times 0 equals 11. Well, 3 times 0 is 0. So now I have minus 2x equals 11, x equals minus 11 halves. Let's talk about that for a second. All three of these numbers are the same. Minus 11 over 2 equals 11 over minus 2 equals minus 11 over 2. Notice the difference. In the left one, my negative sign's in the numerator, it's in the denominator in the middle, and it's in front of the fraction on the right side. All of those are the same. Okay, so our answer, I would say, is x equals minus 11 halves. That's the x-intercept. In other words, I'm getting the x-intercept by substituting 0 for y. Now, am I going to be able to put this in, or do I need a keypad? I'm going to need the keypad for this also?
Probably so, yes.
Yeah. It's 11 halves, right? Yeah. Okay. That's the x-intercept, and we know the y-intercept was 0. That's by definition. Whenever you're on the x-intercept, the y value is 0. Okay?
Yep.
Now, the y-intercept. Well,
So x would be
x is
0.
0. So we're going to do exactly the same process, only
Mhm.
we're going to substitute 0 for x and solve for y. So I got minus 2 times 0 minus 3y equals 11. Going to help me solve that? What's y going to be?
Y equals 11 over negative 3.
Right, minus 11 thirds. Again, doesn't matter whether I put that negative sign in the numerator, the denominator, or out front. Although I guess it does because they're insisting that I use the keypad, which means I have to put it either in the numerator or the denominator. I can't choose to put it out front, if you know what I'm saying. And this is the y-intercept. Whoops, I got this backwards. Hold on a second. Let's see. This should be 0. The x value is 0. And the y value is minus 11 thirds. All right. That should be right. Yeah, the y-intercept is always going to have an x value of 0. Now watch it not like this answer because I got 0 over 0.
So if you go to the x, on the y-intercept, go to the x and just click on the 0 and go back, use your backspace or delete it.
Like that.
Try that.
How do I end up getting, oh, now I go back to keypad. What do I want to push here? Probably any of these values, huh?
I think it's not going to like it.
Yeah, it didn't like me doing 0 divided by 0. Let's see if I put, somehow I got to figure out how to get here. You know what? I have a solution. 0 divided by any number is 0. Yeah, no, it still likes that answer. Notice what it did. It drew the line on the graph. In other words, once I had put in the x and y coordinates for the intercepts, it knows how to draw the graph, and it doesn't know about slope. It doesn't care about slope. Your answer is not in the simplest form. All right. Rather than spending our time trying to figure out how to solve my screw up, how do we advance?
Just go skip.
Okay. All right. Oh, and it gives us a similar one automatically?
Yeah.
That's all right.
You can hit skip again and we can...
Well, let's make sure you can do this. Why don't you do this, and then I'll put in the answers and we'll be beyond this. So it wants the x and y intercepts. So start with either one you want. We'll start with the y-intercept.
Okay.
It's the top one.
So we need to...
What do I do in the next line?
So it'd be negative 6x multiplied by 0 plus 3y.
Well, I'm actually going to plug in x4 or 0 for x there.
Okay.
Okay, plus 3y equals minus 14. This always goes away. I didn't really need to write it. So y equals minus 14 divided by
3.
Okay, so that's the y-intercept. Let me see if I can get it in here right this time. Minus 14 divided by 3, and Man, I did it again. What is wrong with me? Let me try backspacing now. For some reason, I keep wanting to put the y-intercept in that first spot, and that's actually the x-coordinate, so I need to put 0 in there.
Try hitting the fraction thing again. See if it disappears by hitting that again.
Ah, very good.
There you go.
Yeah. Okay. So I want the 0 is the x-coordinate. The y-coordinate is where I have to put in the fraction. And that is minus 14 divided by 3. And now the x-intercept, which is where y is going to be 0. Let me put that in so I can't screw it up. And now let's solve this thing for the x-intercept.
So it would be negative 14 over it's negative 14 over negative 6, which would be positive, right?
Correct. So not only positive, but that can be simplified.
Yes, so that would be divided by 2, right? So
correct.
7 over 3.
There you go. And then immediately they draw the line, which I thought was kind of interesting on the last problem. They drew the line, but they didn't accept my answer. This one will like it. All right. So, go to the next one and see what it looks like. Same problem. Notice
we have a 0.
Both of them have to be 0. So 0, 0, 0, 0. That means that the straight line runs through the origin. Let's go ahead and answer it. You don't get any credit or anything for answering these, do you? These are just practice?
Just purely practice.
Okay.
I wish I got some credit, but unfortunately it all is based on a test.
They didn't like my answer, and I see why. Yeah, y can be any, no matter. Yeah, there's more than one equation or more than one solution here. That is one solution, but unfortunately that point that I put in does not create a line. It creates a point. And they wanted me to put in 2 ordered pairs. So let's rethink this. 8x plus 3y equals 0. Well, it takes 2 points to define a line, okay? And the only thing I've put in is 1 point. And that point is on the line, you'll see. In other words, 0, 0 is a solution. But it doesn't give me 2 points. It gives me 1 point only. So I'm going to pick a value, anything I want for x. Let's pick a nice easy number, 1. And now solve for y. Well, I'd subtract the x, so I get 3y. I would subtract the 8. So I get 3y equals negative 8. You with me? Which makes y equal negative 8/3. So when x equals 1, y equals that. So that is 1 point on the line. let me go back in here and put that in there, and hopefully it'll let me recover. Minus 8/3. Okay, I even kept my original point 0. Notice that my original point is still the B coordinate.
Mm-hmm.
And it's fine to have the B coordinate be 0, 0, because that is now a second point on that line.
Mm-hmm.
So I'm fine with that. Because all they wanted was 2 points. When they say 2 ordered pairs, they mean 2 points.
So really that first point could be anywhere then, right?
Well, it's got to be on that line. In other words, it could be, yeah, are you talking about the point 1, minus 8/3?
Yeah.
Yeah, I could have picked anything I wanted for x. In other words, we're looking at an equation that has an infinite number of solutions.
Mm-hmm.
I can pick any number I want for x, and I could solve for the proper value for y. And all of them are going to be on this line. In other words, that is the equation of a line, and there's only one line that it can be, and that's the one that it is, that they've shown here.
Mm-hmm.
Okay? But you can see that there are an infinite number of points on that line. In other words, if I go up and let x be minus 3, then I can tell that y would be 8. I could have put in that point. But since I did already put in 0, 0 for b, that's as good a point as any.
Okay.
These are all starting to look the same.
Mm-hmm.
You tell me if you want to go forward or you want to do more of these.
Now let's go to, if you hit save and end practice. Let's go to the next chapter. You can say save and exit. Because I can come back here and...
Yeah, you can finish those up, and that'll tell you whether or not you need to go back and review it. In other words, you should be able to probably do the rest of them in that section. And so that's a good point to get to, especially since on your own time, you can go back and verify that you're getting it.
Mm-hmm. So let's go to chapter 2 again. Let's do that. Number 2.2.
Just keep going in order. Okay. All right. There is a standard format in math for a straight line. There's actually a number of them, but this is the most common one. Y equal mx plus b. This is called the slope-intercept formula, where m is the slope and b is the intercept, the y-intercept, not the x, the y-intercept. So if I have this equation, y equal 2x plus 4, I know immediately that my slope is 2 and that my y-intercept is 4.
Mm-hmm.
Well, that allows me to graph it. As long as I start at the y-intercept, there's 4, so I know that point is on the curve, on the line, excuse me. And now to get the slope is rise over run. That's the way to memorize slope, is rise over run. And then slope is the change in the y, which is the rise, over the change in the x, which is the run. So for me to put a slope on here that is equal to 2, I got to go up 2 and right 1. So if I go up to 6 and write 1, my next point ends up right there.
Mm-hmm.
Now if I connect those 2 points, there's my line. And notice that I've got the y-intercept correct, and I have the slope correct, because I've got to go up 2 and to the right 1
Mm-hmm.
to make that second point. And that's all I have to do. Okay? So, to answer, determine the slope and y-intercept. Well, the slope is 2. And the y-intercept, the x value is always 0. The y value is 4. Now, interesting that they didn't draw the line on there this time. But, because I would have thought they would. Yeah, wouldn't you think they'd draw that line? They've been drawing that line on every graph, even though they didn't ask us to graph it. Now, notice that also with slope, they have an undefined there. Talk about slopes. What's the slope of that line right there, approximately? 45-degree angle is a slope of 1. In other words, I'd have to go up 1 and over 1 to get to that line.
Mm-hmm.
Okay? If you have a higher slope, it is steeper. Slope of that might be 3. If you have a flatter slope, slope of that might be 1/2. All 3 of those are positive slopes. What's the slope of a horizontal line?
Well, it's wherever it's passing through, right?
0. Notice what these slopes do. As they go from steep to medium to flat to flatter, that's maybe 1/10. Well, when they finally reach horizontal, it's 0. So the slope of a horizontal line is 0. Now let's go the other way. Let's make the slopes be steeper. Well, that slope right there is probably 10. That slope right there might be 1,000. So what do you think the slope of a vertical line is? Infinity.
Okay.
Or undefined. That's what they mean when they say undefined.
You're saying a vertical line is undefined.
Vertical line is undefined, but you can see from the progression of these slopes that that means the same thing as infinite, infinitely large. These slopes are getting bigger and bigger and bigger the closer I get to a vertical line. Well, when I get a vertical line, the rise is essentially infinite, the run is 0. When you take a number divided by 0, you get infinity. But they don't like to use the word infinity in algebra, so they call it undefined. So horizontal lines have a slope of 0. Vertical lines have a slope of undefined. Now, just to test you, tell me whether these slopes are positive or negative. Positive or negative?
At which point?
The slope is the same across the entire line.
I'd say that's positive.
Correct? How about that one? These are supposed to be straight lines that I'm drawing, but
Positive. Positive?
negative.
Why? Because it's on the...
Here's kind of the way I think about it.
Uh-huh.
Put a ball on the top of the line like that.
Mm-hmm.
If that ball rolls to the right, it's a negative slope.
Mm-hmm.
If I put a ball over here, that ball's not rolling anyway. It's staying right there.
Mm-hmm.
That's a positive slope. If I put a ball right there, that ball's not going anywhere. At least it's not going to the right. Okay? That's a positive slope. So for the ball to roll downhill means it's a minus slope.
Okay.
Put some more. This is an important concept that you know positive from negative slopes. So not a horizontal line, incidentally.
Negative.
Good. And that one.
Positive.
And that one.
Positive.
And that one.
Negative.
And a horizontal line.
Horizontal.
0. The slope is 0. Now, don't confuse 0 with undefined. They're actually a long ways apart. 0 is 0 on a number line. Undefined is out towards infinity.
Mm-hmm.
Okay? So the slope of a horizontal line is neither positive nor negative, but 0. The slope of a vertical line is neither positive nor negative. Its slope is merely undefined. M equals undefined. Although I actually prefer to think about it as infinite.
Okay.
They mean the same thing. So now that we've talked about that, that's why they give us an undefined there. Is if it were a vertical line, then it would have an undefined slope. Well, a vertical line looks like this, x equals 3. That's a vertical line. So if this would have been the equation instead of y equal 2x plus 4, then I would have had to put undefined for slope. Because this is a vertical line. Vertical lines have an undefined slope. And they don't have a y-intercept unless they happen to be right on top of the y-axis. So that would be tough to enter. There is no y-intercept. Notice that a vertical line, if I plot x equals 3, never crosses the y-axis.
Mm-hmm.
So there's no y-intercept when you have a vertical line, ever. No matter where my vertical line is, it could be at -5, it could be at -0.5. It's not ever going to cross the y-axis. All right. Okay, this looks like the same problem. They just want us to plot the y-intercept. Well, I can see what's the y-intercept?
4. And it's up 2 over 1, right?
I'm sorry?
It,
The slope is 2 over 1, yes.
it's up 2 and over.
Oh, up 2 and over 1. Yeah. In other words, they didn't actually ask me to do anything other than plot the y-intercept, so I'm going to leave the answer as what I've done there.
Okay.
If they wanted me to plot the line, then I need another point. And I could go up 2, and I was somewhat mistaken when I used the terminology over. Over doesn't tell you which direction. In order to make a positive 2 slope, I would need to go up 2 and to the right 1. That's why I went through my little exercise about positive and negative slopes, is because it tells you which way you need to go over.
Okay.
That, oddly enough, is a universal problem in all high schools that I've ever worked with. All students will tell you go up to and over instead of saying go up to and to the right one. Because notice that I could go down to and left one.
Mm-hmm.
Gives me the same line, same exact line. So I don't know how it ended up like this, where everybody says up and over, because up and over doesn't really spell it out. You need to go up and over a certain direction. It either has to be to the right or to the left. All right, I think this is the right answer, so I'll go ahead and submit it. Yeah, okay. And next, same equation. Plot a second point on the graph other than the y-intercept such that the slope of the line is equal to the equation. Well, my y-intercept was at 4. And here's where I'm going to go up 2 and to the right 1. There's my second point.
Mm-hmm.
Notice that it still goes through the y-intercept. It remembered it from the last question.
Mm-hmm.
So I don't have to actually put the y-intercept on there again. Just says plot a second point. There you go. We have a positive slope. It's up 2 and to the right 1. Notice that it's also down 2 and left 1. That also puts you on that line. So you can always do either one. The most important thing to remember about slope is rise over run. It's not run over rise. It's rise over run. And then you can almost always figure it out once you do rise over run.
Okay. So I think we're about out of time here, David.
Yeah, it looks like it. Okay. That sounds good. Do you want to keep track of how far you get here, and then you can kind of restart me every time we have a session, or do you want me to make a note of it?
Oh, I can restart you. I'll go back and review it.
You'll always know where you want to start, probably. It might not always be where we left off. Okay, so I won't keep notes as to our progression. I'll just kind of let you start me wherever you want at the beginning of a session. Now, the next time we have a session, I don't need to call you first.
Okay.
What I do is just text you the meeting ID number.
Okay. So I booked one for Friday.
Saw that.
But I wanted to go in and pay for this session.
Okay.
How do I do that again?
Go to digitalmathtutor.com.
And do it there, right?
I'm sorry, what?
And do it there through the PayPal?
Yeah, that's the best way. If you go to digitalmathtutor.com, there is you might even have to go scheduling a session, and then there's a buy now button.
Okay.
And the only thing you have to do is put in the amount. So if you're paying for this session, you'd want to put in 32 and then proceed, and it's going to ask you for your password, and go ahead and put that in, and it'll make the payment. It's just a few keystrokes.
Okay. Well, I'll be talking to you on Friday evening sometime.
Sounds good. Sounds good, Darren. I will talk to you on Friday.
All right, thanks.
Also, I will send you a copy of the recording of this session. I don't send you a copy of the recording. What I do is send you a link that lets you find it on my Digital Math Tutor YouTube channel. Your file name will have your initials, DG, along with the date, 032217. So that'll be your file. Okay? Now, I presume is all, how do I get out of here? I don't want to leave you so you can't get in.
So just go to save and end practice, and then save and exit. Then close out of the Hawks Learning. Close that tab. And then scroll up.
Is there a sign out maybe?
Hit those little 3 deals there. Okay, go to me.
Log out.
There you go.
Okay.
So we can do the same thing on Friday. We can log back into this. And
Yeah, I've got the password and username saved, so you're not going to need to send it to me, and I'll be able to pull this site up and log in. In fact, let me save. This is where I should have saved last time.
Feel free to access this website and take the test for me anytime.
I cannot tell you how many offers I've had over the last 8 years for people that want me to do that. And
have they paid any money?
I just always tell them the same thing. I don't do that. I'm in the business of teaching you the math, not in taking tests for people. But I'm sure you were just joking anyway.
Not really. All right, I'll see you Friday.
Okay, Darren. Bye-bye.